Welcome to Science and Cooking, where we dive into the science behind every dish we make. Today, we're cooking up some classic spaghetti and diving into the science behind heat transfer. First, we're going to talk about conduction, then convection, and finally, radiation. Let's get cooking. Before we can begin to make the sauce, we first have to let the ground beef thaw. This is a perfect example of heat equilibrium. When we place the frozen beef at room temperature, the heat from the surrounding air begins to transfer into the beef. The beef, which is much colder, absorbs the heat and its temperature starts to rise. Over time, the temperature of the beef and the room will eventually balance out, reaching what is called heat equilibrium. At that point, the beef will no longer be thawing because it has reached the same temperature as its environment. Now that the ground beef has thawed, we can begin to make the sauce and talk about our first type of heat transfer, which is conduction. Conduction is the transfer of heat through direct contact. This happens when food directly touches a hot surface, like a pot or a pan. As the meat touches the pan, heat is being transferred directly from the pan into the meat. Remember, whenever food touches a hot surface, heat is being transferred directly, and this is conduction. Now, let's talk about our next type of heat transfer, which is convection. Let's talk about convection. This type of heat transfer happens in liquids and gases. Convection occurs when warmer areas of a liquid or gas rise and cooler areas sink. This creates a continuous flow or current that spreads heat throughout the fluid. This movement helps evenly distribute heat to cook your food. As the water heats up at the bottom of the pot, the hot water rises to the top and the cooler water from the top moves down to take its place. This constant circulation helps cook the spaghetti evenly. Convection is crucial when you're boiling water because it ensures that the heat is spread throughout the liquid, evenly cooking your ingredients. Now, let's talk about the final type of heat transfer, radiation. Radiation is different than the other two types of heat transfer. It doesn't need matter to transfer heat. Instead, it uses electromagnetic waves like the warmth you feel from the sun. Take a look at this perfectly toasted garlic bread. When it was in the oven, the heating element got hot and emitted radiation. This radiation traveled through the air, directly heating the surface of the bread without any physical contact. This is how the bread got its crispy texture. Today we explored the fascinating science behind the classic meal spaghetti, from conduction, where heat transferred directly from the pan into the ground beef, to convection, where heat circulated in water to cook pasta evenly, and finally radiation, where heat from the oven crisps up our garlic bread. Each type of heat transfer plays a crucial role in creating the perfect meal. As well, we took a look at heat equilibrium, where we saw the heat from the air slowly warm the frozen beef until it reached room temperature. So the next time you're in the kitchen, remember, it's not just about the ingredients. It's the science behind it that makes all the difference. Thanks for tuning in to Science and Cooking. See you next time.